Hi class, welcome to another session on digital principles in system design. So we have been discussing synchronous sequential circuits where we had discussed up counters in the last session. So let us move on to down counters and bidirectional counters. So a down counter is a circuit that counts down from a maximum value to a minimum value. So if I am to design a 4-bit down counter, my counter can count from 1111 to 0000. So, if like I said in the last video, if you're designing a 4-bit counter, then you have to use 4 flip-flops, right? So, if A, B, C, and D are my 4 flip-flops, then QA, QB, QC, and QD are the 4 outputs. Now, if here for down counters, let me just take my pen out. Yes. So for a down counter, you can see that QA again toggles for every clock pulse. QB changes whenever QA is 0. So whenever QA is 0 in the next clock pulse, QB changes its state. Again here, when QA is 0 in the next clock pulse, QB changes its state, and so on. Now, if you observe QC changes its state when both QA and QB are low. So here both are 0 and 0. So in the next clock pulse, QC is 1. Sorry, 0. And then again here both when QA and QB are 0, the next clock pulse you can see that QC is 1. So QC is changing state whenever both QA and QB are 0. Similarly, QD is changing from 1 to 0. The transition is occurring here when all other three Q values are 0. Again, the next time it changes its state to 1. Apologies for the 17th row has gone out of screen, so I apologize for that. But the point is, when both QC, QB, and QA are 0, then my QD is again changing its state. So we'll apply this principle, which is exactly the opposite of the up counter principle. So we'll apply this to design the circuit. So like I said, QA changes when flip-flop A is in toggle mode. So QB changes its state whenever QA is 0 or Q-A is 1. Right, the reset output is 1. So if reset output of flip-flop A is 1, then QB would change its state. If the reset output of both flip-flop A and B are 1, then QC would change its state. And then when all the three reset outputs of all the three previous flip-flops are 1, then QD would change its state. Again, I have used JK flip-flop here. You can use any flip-flop of your choice. I'm sure it's going to work. The logic is same. It would work for both T as well as D flip-flop. It's similar circuitry. So let us just move on to the circuit design now. So my outputs are QA, QB, QC, and QD. However, the input that is fed to the next stage is QA dash, right? So QA dash is fed to J and K. So when QA dash is 1, flip-flop B would give me an output 1. And then again, QA dash and QB dash are ANDed together and fed to the J and K of flip-flop C. And then the AND output of A and B. So this is QA dash dot QB dash. Excuse my handwriting. So this is the output of this AND gate. So that when ANDed with QC dash would be the inputs for the fourth flip-flop, J and K. So this is how you design. Of course, you need to give a clock pulse, which is individual clock pulse to all the 4 flip-flops. So all 4 flip-flops are triggered simultaneously to avoid propagation delay. I mean, it cannot be avoided totally, like I said, but it can be reduced significantly when you compare with synchronous circuits. So the overall output is going to be QA dash times, the overall output propagation delay is going to be the same as the propagation delay of one flip-flop plus the propagation delay induced because of these 2 AND gates. So that's the only propagation delay that the circuit's going to encounter, which is much lesser than a similar asynchronous circuit. So moving on to up down counter. So it is like I said, you can use the same circuit as an up counter or as a down counter. It just depends on whether you're feeding the input to the next stage through Q dash or Q, right? Whether the set pin is used to give the input to the subsequent stages or the reset output is used to feed used as input for the subsequent stages distinguishes whether a counter is an up counter or a down counter. So if I use the same circuit and have an additional input called the mode signal, and I design my circuit in such a way that if mode is high or mode is 1, then the system would work as up counter, and if mode is 0, then the same system would work as down counter. Right? So I can use the same JK flip-flop logic and then develop a bidirectional counter. The same circuit, depending on how you are wiring it, can be used either as an up counter or a down counter, or you can have an additional input along with your clock and your logic 1 that can be called the mode, and that can be used to switch between the up and the down counter. So let us have a circuitry. Okay, I've used it. I got a circuit with using T flip flop. This circuit was taken from a textbook like Digital Principles by Morris Manor. So here you can see that there are the up and the down logics, right? You have the clock pulse. So up and down logic. So there's this up one has got an inverter connected to it, and then this would be used to toggle between the inputs. So suppose up is, if you want up counter, then you just use the up signal and OR it with whatever is the output of your down. So one has to be high and one has to be low, and then this AND gate would give you the output accordingly. And then you can use this combination of logics to feed your input to your T flip-flop and then get your up or down counter. So here you can see Q dash is also ANDed. So if you're choosing to use down counters, then Q dash will be fed to T. And if you're choosing to use the up counter, then Q would be fed into T. So there's an AND circuit, AND logic here, and an OR logic. So which would decide what input is going to go into T. And again, all these inputs finally depend on whether you choose the up or the down. So which out of the up and down is high would choose whether Q dash is fed into T, the subsequent T flip-flop, or Q is fed into the subsequent T flip-flop. I hope you had a very fruitful session learning about counters with me, and I wish you all the very best, and I hope counter design would be simplified for you. Thank you very much for watching the video. Bye bye.